Thank you. We're rolling again. Why don't I pause? If I didn't have it paused to begin with, it would do that. Now it seems to not do that anymore. I guess at some point, actually I can get one myself. Other questions before we actually do math? All right, leave the 1/2s in or take them out. All right, so we multiply both sides by 2, get rid of them, or divide by half. So now I'm left with 18 times 4 squared is equal to, what did I say for k? 21 times delta x final squared. 18 times 16 divided by 21. Assume somebody's done this on the calculator already.
13.7.
What is it?
13.7.
13.10? 0.7. And that's delta x squared.
3.7.
Units?
Meters? Yeah.
It's the distance. So that box is going to hit the spring, it's going to compress the spring 3.7 meters, which would be probably a little bit taller than the roof. I think that's roughly 3 meters. And if you're comparing to what you did the first time, I used different numbers. There was a look of panic in your eyes.
Yeah, no, we just went to tutoring, and the last time, on Tuesday we went to tutoring, and he emailed us after the fact. We turned the last master set in, that he gave us the wrong answer. Not gave us the wrong answer, but showed us that it didn't get an answer wrong.
Was it Mike?
Yeah.
It was not wrong.
Next time you see him, tell him that I'm looking at him askance over my glasses and just wondering, who raised you?
It was the one that actually Ty asked to do.
Ah.
Yeah.
Can I show you? This one. I added the NPE within my,
Okay. Yeah, there's nothing wrong with that as long as you got rid of them.
okay, and then I understand because the normal and the blue cancel that.
Right, they don't do any work.
So I just put
Okay. That's fine. Yeah, I used to teach it so that when it came to the potential energy, you just write down all the potential energy formulas and then just get rid of the ones that don't apply. That seemed to confuse more students than not, but there's nothing wrong with starting out with all of them and then just getting rid of them. Other questions? Sausage bar in your eraser. I don't see it. All right, so let's talk a little bit more about momentum, and then we'll morph into rotational motion. I have an object of a mass, let's just say 10 kilograms, heading this way, going 5 meters per second. And I got another mass here, the exact same amount, going at 0 meters per second. So this is the initial startup. just for the sake of convenience, I'll make it to the right positive. What is the initial momentum of the system?
50 meters per second.
So close. Try the units again.
50 newtons per second. Newton seconds.
Yes.
What principle is
What I refer to as Ed's disease. All right. So that is my initial momentum. Because what its momentum is,
0.
yeah. All right. What's my final momentum?
Same.
This, yeah.
Yeah, assuming it's a closed system. What would you expect to happen? Oh, sorry, I guess I need to give a type of, if they stick together, what would you expect to happen?
Conservative, that energy is conserved.
If they stick together, it definitely was not conserved.
I mean, no, it's energy's lost.
Yes, one of the two.
But
If they stick together, a perfectly inelastic collision. If they stick together, well, how fast will it go?
Half as much velocity because you're doubling your mass.
So I assume half of that.
Yeah.
I hope so, yeah. Because that's gonna be equal to my total mass afterwards if they stick together, 20 kilograms times my final velocity. So my final velocity, 2.5 meters per second. So if they stick together, the perfectly inelastic collision, they're gonna stick. Now, let's change around a little bit. Let's make that 30 kilograms. No, I want to make it 20. That's where I'm heading with this. Now how fast is it going in a perfectly inelastic collision? First off, does my initial momentum change?
no.
Okay. So, what do I do now? How do I solve for final?
Divide your new mass by your total momentum and you'll get 3/5.
Okay, I'll go with the spirit of what you said. You worded it backwards.
Oh, did I?
So I now have 30 kilograms there, and then, oh, so we actually, you work it backwards too.
Oh, I did, yeah. I see where I'm going.
So 5/3
Yeah, but
meters per second, 1.6. So when they sit together, definitely you would expect it to go more slowly. All right, this next one I want you to work, give yourself a minute to actually come up with the answer before we do it as a class. Any questions on this before I erase some of it? Or try to erase some of it. Make that 10 again. Make that 20. Don't forget on the quiz or test to put down units.
Is it 10 up there? Yeah.
You're off by, when you divide by that, you have 10. You're almost there. Is that a 10 on top? Yeah. Don't forget this. I think people are. Wait, what's your head shaking there for? You're right. All right, so it looks like people are generally on the right track here. Total momentum beforehand is 100 Newton seconds. And it still combines 30, and so you end up with 10/3, or 3.3 repeating, or 130ths, whatever your mood is today. Questions? Because I'm going to attempt something with you which I have not attempted with a 110 class before. So what you literally ready? All right. We'll start out with if I have let's stick with it. 10 kilogram object going at 5 meters per second. We'll make to the right positive. What is the initial momentum? This is not the tricky part yet.
At 50
Newton
seconds.
What is the kinetic energy?
joules.
Yep. All right, so here's the question. I want a different velocity for this mass, which has the same magnitude of momentum and the same energy. Exact same kinetic energy and same magnitude of momentum.
But you said different mass?
Different velocity,
Different velocity.
same mass, just to make life simpler. So, I want same kinetic energy and same magnitude of momentum.
-5?
Sorry?
-5?
The velocity?
Uh-huh.
So if the final velocity, or if the velocity is -5 meters per second, my momentum will be -50 Newton seconds. So they have the same magnitude, so that's taken care of. And kinetic energy is 1/2 mv squared. And that v is speed, not velocity, so any direction goes away, so that also would be 125 joules. All right, so absolutely. All you do is just change the direction of the velocity, momentum magnitude is the same, and kinetic energy is the same. Questions about that, because we're about to make it more complicated. All right, let's do this. This thing is cruising along at 5 meters per second. So we're all standing here watching this thing go by at 5 meters per second, which is roughly that pace right there. Suppose, as an observer, this thing's moving 5 meters per second to the right. As an observer, I'm also moving 5 meters per second to the right. So this box is moving, and I'm moving along with it. How fast is that box going relative to me?
Twice as fast?
Sorry?
Is it twice as fast or?
With the wrong direction. Dulce?
Zero?
Yeah. If it's going along with, if I were going 5 meters per second, that way it would be twice. But I'm going along with it. It's moving right along with me. So, if the observer, so the velocity of the observer is 5 meters per second, this, the velocity of the box, would be 0 meters per second. Suppose I'm going 10 meters per second. What would the velocity of the box be? By the way, this is known as the lab frame.
5 meters per second?
Not the velocity.
We go the same direction as the box,
I'm going the same direction, but I'm going 10 meters per second.
so -5.
Yes. It looks like it's moving behind me. I'm outpacing it, it's going behind. So minus 5 meters per second. And if I'm going negative 5 meters per second, how fast is the box going to seem like it's going?
15 or 10?
10. And this is Jonathan's answer the first time. All right. So how fast it's going really depends on how fast the observer is going. So in this case right here, what is the momentum of the box? According to this observer.
0 meters.
I'll just put the seconds up there, so 0. What about in this case? What is the momentum of the box? And in this case,
100.
so the momentum changes depending upon who's observing. Questions to hear? This is about to bring in a second object. All right. Let's bring in a second object. So I got my 10 kilogram box moving this way at 5 meters per second in the lab frame. I got another box over here, let's say it's a 6 kilogram object going this way at 4 meters per second. In the lab frame, what's the momentum of, actually, I gotta change these numbers because I want them to come out better. I'm still gonna get a fraction there. at least the fraction won't be too bad. All right, so what's the momentum here? Again, make to the right positive.
60.
Momentum here,
Minus 20.
the total,
40. 40.
all right. Questions about how we got that? This is the kind of stuff that we had been doing. So the velocity of the observer. So if the observer is going 6 meters per second, what is its velocity?
Observer goes the same direction.
Yes.
0.
Yes. So my velocity here, velocity of the 10 is 0 meters per second. And so what is its momentum?
0.
And over here,